The problem one, it asks us to find out the following processes. It's a probability mass function or density function, the mean, and the autocorrelation. So for the first one, the pursuing process, the first order probability masses is p of x of t equals to k equals to e powers minus lambda t and lambda t power of k all over factor of k, and the mean is the expectation of x of t is equals to lambda t. The autocorrelation is lambda times the minimum value of t1 and t2, and the autocovariance is lambda times minimum of t1 and t2. And the second one is a Poisson increasement process. Its first order probability masses is p of y of t equals to n over sigma, and it equals to e power of minus lambda sigma lambda sigma power of n over n, and the mean is lambda, and the autocorrelation is r. It has two cases. The first is that if the absolute value of t1 minus t2 is greater or equals sigma, and so the autocorrelation is lambda square, and otherwise the autocorrelation is lambda square plus lambda over sigma minus lambda times t1 minus t2, the absolute value of t1 and the t1 minus t2 over sigma square. And the autocovariance is also two cases. First is that when the absolute value of t1 minus t2 is greater than sigma, and is 0, otherwise is lambda over sigma minus lambda times the absolute value of t1 minus t2 over sigma square. Third one is the Poisson process, and it does not have a probability mass function, and the mean value is lambda, and the autocorrelation is lambda squared plus lambda times the impulse function of t1 minus t2, and the autocovariance is lambda times the impulse function of t1 minus t2. And the fourth is a semi-random telegraph signal, and so its first order probability masses is e powers of negative lambda t times e of lambda t minus e of negative lambda t over 2, and the mean value and the mean is e powers of minus 2 negative 2 times lambda times t, and the autocorrelation is e power of minus 2 times negative 2 times lambda times the absolute values of t1 minus t2, and the autocovariance is lambda powers of minus 2 lambda negative 2 times lambda times the absolute value of t1 minus t2 minus e powers of negative 2 times lambda times the sum of t1 and t2. And the fifth is the random telegraph signal, and the first order probability masses is 1 second, and the mean value is 0. The autocorrelation is e powers of -2 times lambda times the absolute value of t1 minus t2, and the autocovariance, which is the same, is e of -2 times lambda times the absolute value of t1 minus t2. And the sixth is a random walk, and its first order probability masses is the combination of n and n plus r over 2 times 1 over power of 2, and the mean value is 0. The autocorrelation is the mean value of n and m times s squared, and the autocovariance is the mean value of n and m times s squared. And the seventh is the Wiener process. Its first order density function is f of w and t equals to 1 over the square root of 2 pi times alpha times t times e power of negative w2 over 2 alpha t, and the mean value of it is 0. The autocorrelation is the minimum value of between t1 and t2 times alpha. The autocovariance is the minimum value of t1 and t2 times alpha.